the pink section. Okay, I'll give it to you guys. I did mention it. I just want to make sure. This is the minor arc. Minor arc. And then the blue that goes all the way this way would be the major arc. Major arc. So minor arc and major arc. But anyway, we're looking for the minor arc. And we know, what is 18 referring to? $18 is the circumference. Good. So we're going to set up a proportion. And I see that Perla already got us started on it. So my proportion is going to be 120 over 360. So 120 over 360. And what goes on the other side? What goes on the other side? X over 18. Good. So the circumference is the whole, and the x is part of that whole, right? So we always put whatever's in the numerator is the part, the denominator is the whole. So part over whole. Okay, now I can go ahead and solve. So we know there's a couple ways to do this. Cross multiplication will always get you the right answer, but I know that sometimes it can be easier if you simplify the fraction. But I always like to go with cross multiplication because it always works and we're not going to make any mistakes by doing it. So what do I get? 120 times 18. 2,160 equals 360x. Now we can just divide, and what do we end up with? 6. Good. Good, good, good. Any questions on number 1? Good. Okay, now what's different about number 2? Okay, so physically, yes, it looks different, but they give us the radius, they don't give us the circumference. So we need to find the circumference first. How do I find the circumference from the radius? Good, 2 pi, I'll write actual pi, 2 pi r. 2 pi r. So if my radius is 3, what would be my circumference? And so they're telling us either enter an exact answer in terms of pi or use 3.14. Let's keep it as pi. So what Janelli says, that's what I'm going to use, 6 pi. So because the radius is 2, so it's 2 times pi times 3. Oh, the radius is 3, sorry. So I'm just going to leave it as 6 pi. And that's more exact. The reason we do that is because it's more exact. So now let's set up the proportion. On the left side, what's the angle measurements? $20 over 360. And now that we know the circumference, we can fill in the right side. So we're still looking for x. We still don't know that portion of the circumference, but we can write x over 6 pi. And we basically just treat pi like a variable. We're not gonna use any numbers for pi. We just keep it kind of like a variable. So what do I get here? 120 equals 360 pi. Sorry, 120 pi, oh my goodness. 120 pi equals 360x. Don't make that mistake. All right, now what? We divide. We divide by 360, good. What's 120 divided by 360? Good, we're gonna actually keep it as a fraction, Tyrone, okay? So I know you got 0.33333, but we always wanna keep things as fractions because when you have a repeated decimal, like 0.3333333, that is a fraction. You can write it as a fraction. So it's better to keep it that way. So when we simplify 120 divided by 360, we end up with 1/3 pi. Yeah, Pi Day is on Sunday. We gotta make some plans. All right. Questions on number 1 or number 2? Going once. Going twice. Okay. So today we're going to move on to a new topic. We're going to be working on central angles and inscribed angles. And we kind of already talked about central angles, actually. So if we remember in the problem that we are looking at right now, where is my central angle in number 1? Oh, I'm drinking tea. Good. This is the central angle. So we've talked about central angles already. We already know what those are. So the only new thing we're learning about is inscribed angles. So as always, we have some definitions. I've got 3 on the board. Can I get 3 volunteers popcorn it out to read these 3 definitions?
A chord is a segment whose endpoints lie on a circle.
Okay, number 2.
A central angle is an angle less than 180 degrees whose vertex lies at the center of the circle.
Perfect. Then the last one. Pila, go ahead.
I was trying not to read. Oh man, my mic is open.
It's fine.
An inscribed angle is an angle whose vertex lies on the circle and whose sides contain chords of the circle.
Awesome. Okay, so here we are. We have the 3. So I want you guys to write down the 3 definitions, and we're going to draw out these diagrams. Now, it's going to be a lot easier to draw this out if you have the right tools. So if you happen to have your compass, now's a good time to use it because with your compass, you can make a perfect circle. If you don't have your compass with you and you want to make as perfect a circle as possible, if you have a water bottle or something else circular nearby, you can trace it on your piece of paper. It's just the best way to do it. If you don't have any of those tools, then you're just going to have to draw the best circle you can, but without the tools, it won't be perfect. So go ahead and draw your 2 circles, and then we're going to label each of those parts. Okay, so I'm just going in and I'm just labeling each part for both of these circles. Tyrone, there was a viral video that went around a couple years ago where somebody draws a perfect circle on the board. I think it was a vine. And they're just like and they do it perfectly. Yeah, I think that I've seen it. Vine died because the owner of Vine decided to just shut it down. It's really disappointing. TikTok's different though. The simplicity of Vine is what made it so incredible. All right, so finish drawing, finish writing. And then I have a question for everybody when you're done with that. So I've labeled all of the chords, I've labeled all of the inscribed angles, and I've labeled the central angles. What is the blue, which I've highlighted, but I didn't label it yet? Good, Perla. Those are radii. So in blue, I have my radii. More than one radius is a radii. So now we've got everything. Take another 30 seconds. And does anybody have any questions so far? Does anyone still need a moment to write things down? Okay, I'll give you another 30. Good, Perla. Yeah, chords don't connect with the center because if they did, they would no longer be chords. That would just be the diameter. So chords are basically any line that is in the circle but doesn't pass through the middle. Okay, any other questions? Okay. So we're actually going to do a little bit of a exploration now. And with geometry, a lot of times the best thing to be able to do is actually see what's going on visually. So go ahead and in just a second, you can click on the link in the chat and spend about 5 minutes. Take about 5 minutes to kind of see what's going on in this example, play around with it, move around. You can move every single button around and play around with it and just see if you notice any patterns or anything at all. And then take a look at the 2 questions that are on the board and see if you can answer them. See if you can answer those 2 questions. Why are you using your touchscreen, Tyrone, or what? Oh, okay. So just spend a little bit of time playing around with that, and we'll get back to it in a second. So start seeing if you notice any patterns, and once you've played around with it for a while, you can come back to the screen and see if you can answer those 2 questions that I have up on the board. Nice, Perla. There's a good answer. So everyone go ahead and take 30 more seconds, and then I'm going to share my screen and we're going to do it together for a little bit. All right. So I'm sharing my screen. I have the same exact thing on my board. And let's just quickly take a moment and just see the relationship. So in this scenario, my inscribed angle, the blue one, is acute. So it's less than 90 degrees. And in that scenario, when I slide this over, what do we notice? Good. So we can kind of say it both ways, which Perla just said. So the inscribed angle is half of the central. Or you can say it the other way around, which is that the central angle is 2 times the inscribed angle. Okay, so whichever way you look at it, that is the relationship. Now, here's another question for everybody, and I want everyone to watch. Does the inscribed angle change when I move it around? Does it change at all? Not at all. Okay, so no matter where the inscribed angle is, as long as those 2 dots, so these 2 dots are the important ones because those 2 dots, those same 2 dots stay where they are, right? So I'm moving the angle around, but those red dots stay in their place. Those red dots are the ones that connect to the central angle. So the relationship, no matter where the inscribed angle is on the circle, it is still going to be, ooh, it just did a flip. It's still going to be half the size of the central angle. That's fun. I want to do that again. Whee! Okay. So that's something else that's super important to keep in mind. This can be anywhere, and it's still the same relationship. If I put it over here, notice now I made a diameter. This is my diameter, and the relationship is still the same. Okay, so that's when the inscribed angle is acute. Now let's see what happens when the inscribed angle is obtuse. So there it is. Well, now the central angle, technically the central angle is this one in green. That's the central angle. So let's look at what happens. So in this case, how would I get the missing amount, the green? Let's call that x. If I know that this is 2 times the inscribed angle, how would I get that missing amount? No, we're not going to divide by 2. And the reason we're not going to divide by 2 is because it's not always going to be half. In this case, it kind of looks like it. Well, let's think about it. How much is this circle all the way around? All the way around this whole circle, is 360, right? So if I know how much this is, let's actually put some numbers in because it's always helpful to do it with numbers. So let's say my inscribed angle is 120. Let's say that's 120. How much would this be? Good, 240, because this is twice. So this is 240. So how do I get the missing amount, the green? Nope, easier than proportions. How much is the whole triangle? 360. How much is this portion? 240. So to get the missing amount, you just subtract. So x would be 360 minus 240. Good job, Jalen. $360 minus 240. So let's make it a little bit more generalized now. Actually, I didn't mean to delete that. Okay. So now the central angle is equal to 360 minus 2 times the inscribed angle. Okay, there you go. So the central angle is 360 minus 2 times the central, or the inscribed angle. I'm going to write this on the other screen as well. So do I have any questions on that? Okay, so let's go ahead and summarize everything on the main board. Here we go. So in scenario number 1, when the inscribed angle is less than 90 degrees, so when it's acute, we know that the central angle is equal to 2 times the inscribed angle. Yes, we will have a quiz on Friday. Okay. And Jalen, GeoGebra is like a really cool, it's the website we were just on. It's really, really good for geometry and it's free. So it's a way to practice and understand relationships in geometry. Okay. Now, that's example number 1. Example number 2, when the inscribed angle is obtuse, it will be equal to 360 minus 2 times the inscribed angle. So go ahead and, if you didn't have this down before, go ahead and write it down. Tyrone, you have a question? No, okay. Anyone still need a moment? Yes, okay, Perla. Take another moment. Stop writing puns in the chat. All right. Okay. Now, there's a lot on this page, but we're not going to write everything. Okay? Just a couple of things on the very top. We've already written this down yesterday, but for those who weren't here, you might not have it in your memory. An arc, which we just kind of covered in the beginning. The arc is a section of the circumference, right? Now, the thing I really wanted to go over on this page is the measurement of an arc. So just the center column, okay? So kind of want to just highlight this. Can I have a volunteer? I'm actually not going to highlight that. Can I have a volunteer read what's highlighted in yellow, please? Okay, Perla's throat hurts. Let's respect that. Who else can read? Okay, I'll read. The measure of a minor arc is equal to the measure of the central angle. So I wanted to just give an example. Okay, so here's my circle. There's the center. I'm going to call that A. I'm going to call that B. Let's say this is 50 degrees. So remember what I just said, the measure of the arc is equal to the measure of the central angle. So if I say if angle ACB equals 50 degrees, that means that arc AB, so this is the sign for arc, it looks like an arc AB is also 50 degrees. So that example is kind of the most important part. I know there's a lot on this page and you can read through it as a little bit of a review, but the most important part is that the arc measurement is equal to the central angle. So go ahead and write down the example. Now I have a question for everybody because this can get a little confusing. When I say that AB is 50 degrees, is that the same thing as the length of AB? Good. No. So this is not the length. Okay? It's not the length. It's the measurement of its degrees. It's kind of more related to the central angle. Any questions on anything on this page so far? Okay. One last one, but this is easy because it's pretty obvious. A semicircle is half of a circle. So the measure of a semicircle is 180 degrees. And so that's the last thing I want everybody to write down. Semicircle is 180 degrees. Yes, Perla, you're correct on that. All right, any questions? Anybody still writing? All right. Okay, and then as always, there is a theorem connected to everything. So if anyone can read the inscribed angle theorem.
The measure of an inscribed angle is equal to half the measure of its wait, how do you say that?
Intercepted.
Intercepted arc.
All right. So here's my inscribed angle. And here's my intercepted arc. We call it the intercepted arc because you can think about it being kind of cut by A and B. It's intercepted. Now, how do we know? This is interesting. How do I know that the intercepted arc is going to be, that the intercepted arc is going to be twice the size of the inscribed angle? What can I possibly connect on this diagram that isn't connected already? Good, the C. And what did we already find out by doing that little activity before? What do we know about this angle here? That's the central angle, exactly. So I'm gonna write a couple of statements and they're all gonna come back to the original definition of this theorem. But we know from our activity before, we know that A dB, angle ADB, is half of angle ACB. ADB is half of ACB. Then we also know that angle ACB is equal to arc AB. Those are equal to each other. That's the definition of an arc. So putting everything together, I know, let me move this down a little bit. Oops. Okay, putting everything together, I know that ADB is equal to 1/2 of AB, arc AB. So you can go ahead and write those things down. Do I have any questions? Because this is where it kind of starts getting a little confusing. We're still okay? Okay, anybody still writing? Okay, let's try a couple problems. So here's the first one. If ADC is 23 degrees, so if this is 23 degrees, what would ABC measure? Good, Jalen. 46. Remember, it's twice the measurement. So ABC is 46 degrees. Now, on that note, what is the measure of arc AC? How much does AC measure? Arc AC. It's not a trick question. Nope, not 23. Go back to what we just wrote down. $46. They are the same, same exact thing. So just remember, the central angle is the same measurement as the arc that it intercepts. That's the most important thing right here. This thing I wrote in the middle, most important thing. The central angle and the intercepted arc are exactly the same. Central angle and intercepted arc. So now try number 2. If ADC is 20 degrees, so if this is 20 degrees, what is ABC? Good, 40 degrees. And if ABC is 40 degrees, what's the measure of arc AC? Good, also 40 degrees. So that's kind of the basics. So does anyone else still have any questions on that? That kind of clears it up, right? Okay, do a couple more on your own. All right, couple more seconds. Okay, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Okay, so we have to read carefully. If you didn't read it carefully, you probably did it backwards. ABC is 124. Let me use a better color. If ABC is 124 degrees, how much is ADC? Good, 62. This one was backwards. They gave you the central angle, and when you know the central angle, you have to divide it by 2 to get the inscribed angle. Questions on number 1? Okay, number two, similarly, you have to kind of do it backwards this time. If they give you ABC, which is 40, how much is ADC? Good, 20. Now, what's the measure of AC? What's the measure of AC? Yes, good, 124. It's the same as the central angle. And over here, what's the measure of AC? It's 40. Good. Questions on this? Awesome. Okay, let's try another one. This is from the district now, so this is no longer Khan Academy. All right. In the diagram, the measure of angle ACB is 25 degrees. Doesn't mean it's going to be hard, by the way. If this is 25, what's the measure of AOB? Easy, right? Simple, simple. 50 degrees. What's the measure of arc AB? Also 50, good. Okay. Not too bad, right? Once you kind of get the hang of it, it's pretty simple. Go ahead and do this one. Have an answer ready in your head, ready to go. And then we're all going to say it at the same time. Here we go. What is the measure of angle F? Good, beautiful. Okay, if this is A and this is B, what's the measure of arc AB? $30, not 15. Don't get fooled, it's the central angle. Central angle. Oops, that's okay. It's okay to make mistakes now, but not on Friday when you take a quiz. Okay, let's make it a little bit more interesting now. This is a little bit more challenging. So we're looking for the value of x. What do we know about the relationship between angle, let's call this, okay. What's the relationship between angle BAC and arc BC? Okay, so are they equal or is it half? Think about it again. Those are two options. Are they equal or is it half? Uh-oh. Well, does it help if I do this? It's half. So just because they didn't draw, they didn't draw the central angle, but we know that angle BAC is 1/2 of BC. And that goes back to the relationship that we already wrote down in our definitions. Okay, so we already know that the relationship is that it's half, not equal, but half. So now go ahead and see if you can figure it out while I charge my pencil. And if you have an answer, you can send it to me in the chat. All right, let's go ahead and go through it. So BAC is half of arc BC. So that means that 6x minus 12 is 1/2 times 56. What's 1/2 times 56? It's 28. Good. And so, okay, now we just solve for x. Super easy. What do I do to both sides? Minus 12 plus 12. (28) plus 12 gives me 30. No, it doesn't. It gives me 40. I can do math. Gives me 40. Now what do I do to both sides? We divide by 6. And we simplify. So what would be my final answer in simplified fraction form? (20/3). Good. Questions on this one? Okay, so the most important thing is that, remember, the original question did not have the central angle. So you have to be able to do this even without that central angle written in, okay? So we already know, without me drawing the red lines on there, we already know the relationship is going to be half, not equal. All right, so any questions? Okay. Here's one without pictures, so let's read it carefully. What is the measure of a central angle that intercepts an arc measuring 65 degrees? Easy, right? What is the measure of a central angle? Easy. If this is my circle and this is my angle and this is 65 degrees, then the intercepted arc is also 65 degrees. It's a fake question. This is just to make sure you guys are awake. Just want to make sure. We're all awake. We understand. Okay. Free points if you do it correctly, if you read it correctly. Now, I'll make it harder for you, Tyrone. Don't worry. I'll make it harder. What if the question asked this? What if it said, what is the measure of an inscribed angle that intercepts an arc measuring 65 degrees? Perla's finding this too easy. How did she get that number? Yeah, it's half. So if AB is 65 degrees, then the inscribed angle, so remember, inscribed angle does not go to the center, it goes somewhere off to the side. The inscribed angle would be half of that amount. Questions? Okay, one more question. Would it still measure 32.5 degrees if it was located over here? Or would that be something different? Would that still be 32.5 degrees? No, what would it be now? My question is, would this still be 32.5 degrees? Where are you getting 45 degrees from? Oh, no, I'm asking if, okay. Let me go back. That, we already said that this is 32.5 degrees. My question is, if I move it over to somewhere else, like over here, would it still be 32.5 degrees? Yes, it would. What if it was over here? Would it still be 32.5 degrees? No? Why not? Why not? Does it have to go through the center? Think about it. It does have to go through the center. I moved the interception point. No, I didn't. It's still connecting to A and B. I'll draw it a little bit better here. A, and B. So you agree? This is still 32.5 degrees? Yes, it is. Does it matter where on the circle it's located? It does not. So don't get it twisted. Let me do this one more time. I can move this every which way, all the way around the circle, and it's still going to be the same exact measurement. It doesn't matter where it is. Regardless of where it is on this circle, it doesn't change. It can pass through the center. It can be perfectly symmetrical. It can be all the way over here. It can be all the way over there. It's still the same amount. It does not change. As long as it passes through A and B, as long as those 2 points stay the same, this is not changing. Does that make sense? Questions on that? Okay. All right. So now that we've got that cleared up, let's do a bit of a challenge. But I bet you guys can put it together. So here we go. We know that EDF is 15. EDF, I'll label it. EDF is 15 degrees, and we're looking for ABE. Hold on. So that's 15 degrees. And notice it tells us that AF is 44 degrees. And we're looking for ABE, this big one right here. That's what we're looking for. Is there anything that we can fill in? FE is 15. How much does FE measure? Seven? How'd you get 7? 7.5. How'd you get 7.5? It's half of 15. Is that how it works? Think about it, Tyrone. You're really close. It's 30 degrees. You went the other way, Tyrone. Okay, so just remember the intercepted arc is 2 times the inscribed angle. So if FDE is 15 degrees, arc FE is 30 degrees. Okay, 30 degrees. So now I'm looking for ABE. I'm looking for ABE. What's the total measurement of arc AE? Arc AE. Good, 74. Arc AE is 74, so what is ABE? I see Perla wrote 37. How did you get 37? Okay, So ABE would be 1/2 of 74 degrees. Okay, any questions on this one? There's another way you could have done it, but does anyone have any questions on doing it this way? Okay. Now, here's the other way you could have done it. Oops. Is that if that is 15 degrees, how much is FBE? Go ahead. I see Janelli said it privately. So if let me write this down. So if FDE equals 15 degrees, I'm not changing the points at all. I'm not changing them at all. I'm just moving it over, if you can think about it that way. So how much is FBE? Anyone? Anyone? Good. 15 as well. 15 as well. It's the same measurement because it's going through the same arc. So, okay. So if that's 15, we're just missing this part right here. And how much is this part right here? A, B, E, F. How much is ABF? Not 44. Not 44. 22. Okay. So 15 and 22 give me because we're looking for ABE all together, we get 37 degrees. So this was the other way to do it. Could have done it the first way, could have done it the second way. Both ways you get 37. 38 was 5 plus 2. Okay. So questions on this one? All right, cool. Okay, this is just a special case, Can I have a volunteer please read this theorem right here, the inscribed angle of a diameter theorem? Okay, I'll read it. The endpoints of a diameter lie on an inscribed angle, and if and only if the inscribed angle is a right angle. Let's talk about why that's true. Here's my inscribed angle. I can call this A. Now, I know that BC is a diameter. If BC is a diameter, then what is arc BC? 180, good. And if that arc is 180 degrees, that means that angle BAC has to be half of that amount, which is 90 degrees. Okay, so there you go. So that's why if the diameter if the endpoints of the intersected angle, inscribed angle, I'm sorry, if the endpoints of the inscribed angle are on the diameter, then the inscribed angle is a right angle. So that's a special case. And since it's a right angle, we already know there's a lot of very useful relationships with right angles. So for example, let's look at the first two examples, which are pretty easy, or a little bit easier. So in example A, let me set this up the same way. Which of these is a right angle and how do you know? Good. Angle C is a right angle because AB is a diameter. When AB is the diameter, that's the only time that it's going to be 90 degrees. Well, if this is 90 degrees and the other one is 46 degrees, what's angle B going to be? Do your math a little bit more correctly, Jalen. 44 degrees. That's okay, it happens to me too. Same thing with number 2. We know that this is 90 degrees because AB is the diameter, which makes this 180, which makes that 90. So in this case, what's the measure of angle A? Measure of angle A is good, 53 degrees. Questions on those two? Pretty simple. What about here? What is the radius? What is the radius of circle O? So we're missing the radius. We know a lot of information actually. We know it's a right angle. We know the lengths of CB and CA. How do I find the radius? You guys have 2 minutes before class ends. No one? What's on Sunday again? What's that special day that's on Sunday? Oh, it's Pi Day. Interesting. Did everyone really just forget the Pythagorean theorem? Real quick, 144 plus 25 gives me 159? No, 69, 169. So 169 equals c squared, takes the square root of both sides. What's c? 13. And what am I looking for? Am I looking for the diameter? What am I looking for? What's my final answer? 6.5. Because what am I looking for? The radius. Radius is half of the diameter, making this 6.5. So always look at the question and see what it's asking for. If it's asking for the angle, find the angle. If it's asking for the length, find the length. It depends on the question. There is homework due Friday. I'm putting it up on Khan Academy as we speak. Please make sure you review today's video, you all. I'm not teaching it again. I'm not teaching it again. So it's your responsibility. If you feel a little lost, if you feel a little confused, watch the video again, work on your homework and see how you do. Practice is the only way to get it right. Have a good afternoon, everybody.